Good day. We are still in the KA intro, but this should be our last video. We are looking at page 7 of this beast, as you can see. And what I'm going to be doing is giving you two chemicals, and you're going to have to figure out quite often what the products are. And then you have to look at Ka values to decide which side is the better pusher. And whichever side is the better pusher, in other words, has a bigger Ka, will drive the reaction to the other side. So it says if a stronger acid is on the reactant side, the products are favored. It drives it to the right. And conversely, if stronger acid is on the product side, it drives it left, favoring the reactants. So here I have acid, base, and I see that's my conjugate acid, that's my base. So I can look up the Ka for H3PO4 and the Ka for NH4+. When I do that, I see that this Ka value, 7.5 times 10 to the minus 3, is bigger than the 5.6 times 10 to the minus 10, and so I know it's going to favor the products. This is a stronger acid. It is better at donating a proton, drives it to the right. B, I do the same thing, identify conjugate acids. I say there's a conjugate acid, and there's a different conjugate acid. So I get the Kas for both those. I put it in red to illustrate this is a bigger number, stronger acid, and again, it favors the products. Hopefully not all these say favor the products, or else that's what you're always going to guess. And that will be wrong. Now, this one was tougher. We had to figure out what's going on, so I'll show you how we did that. It's going to be a bit of a mess. We had these two things that both can behave as an acid. I looked up the Ka values for them and I saw this was bigger. That means this is a better proton donor, so it donated it to our hydrogen oxalate ion and it made oxalic acid. Then this has lost a proton, that's F minus. So now I have HF, I have H2C2O4. Those are my two conjugate acids on the opposite sides of the equation. I had this Ka already. Now I look up this Ka. This number, 10 to the minus 2, is bigger than this one, 10 to the minus 4. Stronger acid. So this one favors the reactant. So we'll drive it to the left. So there was a lot going on there. And hopefully the next ones will be challenging as well. Same idea. These ones are both amphiprotic. They both can accept the proton or donate a proton. But I'm going to look at them as acids. So I get a Ka here and a Ka here. Clearly 10 to the minus 5 is bigger than 10 to the minus 11. So this will donate the proton, and that's why I end up with the oxalate ion. This accepts the proton, that's why I end up with oxalic acid. Now, when I get these numbers, I see it's 6.4 times 10 to the minus 5, 4.3 times 10 to the minus 7. This one is stronger, so it favors the products again. And frankly, that's about as tough as it gets. You're going to have an amphiprotics worksheet, and it's going to be questions like this. Follow these steps. Rewatch the video if you have to. But if you're systematic, one step at a time, totally doable.